Hello, in this video I'm going to talk about nocturnal inflammation, and what it does is that it helps in quantum computing, and SPO or superposition value is parameterized by a vector. And to start off with, I'm going to talk about the theorem. The theorem is P1, P2 is the value where the graph is shown. What the value that the graph shows is, so this is the double integral, and this one is the solved value, but then the original value is too complicated to write. And this is the theorem. But if we insert a vector outside of it, if we use complex conjugates, it's gonna work like this. The same value is P1, P2, and this one will be E to an R vector equals to P1, P2. This is the product of P1, P2 is equal to E to R vector. And since we know the theorem now, we're gonna draw the graph, and the graph is going to look like this. It's gonna be like this. This is the X and Y and Z. It's 3D, so well, there's gonna be this, like there's gonna be this thing on the ZY plane. So what we're gonna put it as is ZY P1, P2, P1, P2 equals to the change in value of X, and the X, which will be here, like this, it can go from here and goes in the value of R vector. So this will be delta X equals to R vector. Yes, this is the equation, but the formula for the graph is F R vector equals to integral P1, P2 Hamilton and equals to delta P1, P2. Why we put Hamilton? Because this value can change from up to down, and this too. So we'll put this like this. And actually, if we connect all of them together, there's going to be a sphere, and we call that Bloch sphere. Like a sphere like this. Since we know the graph and theorem, now we're going to solve some questions to better understand what actually it is. So the first question is that there's two Dirac space values, and we're going to draw a graph for each one like this. Now, this time I'm going to draw the Bloch sphere first, because it is the most important thing in quantum mechanics. And this graph, there's Z2, and this is Z, Y, and this is x and this is y, and this is going to be, this is 0 or O, and this, there will be a k value in this one, which will be connecting z and z2, right? This one will be 2 then. 0, 0, 2, this value. And connect z with it, and this value will stretch thiswards or thiswards, up or down, and this is x equals 2. The k value will be when the z value meets with the Bloch sphere. This is going to be k equals to 1. So if you rewrite it, it's going to be like, say that this is P1 and this is P2. P1, P2 is equal to 0, 2 delta k equals to 1. And this will be r vector. And if we plug in the minus phi, it's going to be r vector Hamilton E psi 2 delta k x comma 2 t. This is going to be the equation. So the answer is going to be that because I is smaller than 0, if we put it in, then the answer is going to be, if I is smaller than 0, Hamilton I e t psi x comma 1, this will equal to, since that's Hamilton, I and 2 minus psi x comma t equals to 2 minus 1, and that's 1. So this is 1. The answer is 1 for this. This is the most easy question in the Nocturnal Infammation. The second question is the second easiest question. We need a lot of z for this one. Y, x, z. This one will be SP and P1, P2, K equals 1. And this is constantly going on the value of r vector. So K equals 1, P1, P2, R delta x equals to z minus 1. This will equal to K R vector this. And this equals to K R. Since K equals 1, we won't write it later. But for the easier knowing, we'll have to write it first. R vector delta x equals to z minus 1. This equals to R vector over I T P P1 P2 equals, since ft is equal to t bracket I, we have the same value, so 1 over r vector. But we know how fast r vector is going because k equals 1. So 1 over 1. So this one is 1. And by this, we know that this and this is the same value. And if we know that that's the same value, this leads us to the product set theory. The product set theory. What it is that the Dirac space value, which is 1, if we have this graph, which is 1, is equal to this one, which means that the basic equation is this one. And if since it's a set theory, we talked about set theory last time. This is almost the same value, and this is set theory plus nocturnal inflammation. This is the product set theory. If we plug this in there, for example 0, then it's gonna come out as this one is k equals 1. This will be R1, R2, and leading coefficient 4, right? Minus R delta x. And this is just an equation, and let's put number 1 as an example. So if you put number 1 as an example and try to put this thing, which is very simple. The most simple thing, this simple graph, we're gonna plug this in, and this will be the first value, R ET, comma. There's gonna be 4 values in total because set theory we have 4 values too. The second value, 0, 0. The third value, just plug it in, t equals 1. Since it changed, k equals t. T equals 1, then so 1. The fourth value, this one, is actually, it looks very confusing, but then it's very easy because this will be 1 since t equals to 1. But then 1 represents no value and 0, so this will be 0 too. That's why this is such a simple graph. And then the last, and then the last one and the second one will be always the same in product set theory, because they should have the same value in here. Now let's put the second thing as an example. We're going to try putting this one in, the same value. Putting the same value is very confusing. This one, we're going to put in this one now. Now, we first got to draw this graph because this is going to be the longest problem and the last. X and Y and Z. Now we're going to draw this in the same way we did last time. Draw the Bloch sphere. I wrote 1 equals k right there, but I'm going to fix it this time. This is going into on P1, this one is P2, SP. Alright, that's enough. Now, if you write the graph, we would normally write it like this, just like last time. This one. This is the graph that we wrote last time. Then we need to add, this is the same thing as this one because this is the same graph. We're putting in the product set theory this time, and this is going to be more complicated. Why is it more complicated? It's because set theory explains the whole value. This one explains only the graph and theoretical, but then this explains all possible values. So if you put this in, the first square is going to be R O. I haven't considered this P1 and P2. This is the low value. K equals 1. K equals 1. P1, P2 equals to K2. We don't know what K2 is yet. SP 2 pi SPE pi phi x comma t. And the last value, z minus 1 SP 0, which equals to 0, and this will be 0. This will be 0. Now, this actually became more simpler than I thought. I thought this would be very complicated. But then what I've said is that the second and the last value is always the same. Second and the last value, which means that if we don't know K2, now we'll know what K2 is since we know that the last value is 0. That means that this equals to 0, and since K equals 1, if we put it in, IT K K2 0 and 0. If this wants to be all equals to 0, K equals to K2 equals to 1. So K2 equals 1. Since we know that K2 equals 1, we write the set theory again. Much simpler this time. R delta x factorial comma 1. I mean this is 0. 1, right? We knew that K equals T, so 1 and 0, 2 pi comma 0. So the first part in the video we talked about is nocturnal inflammation, the first theorem. And we talked about vector interjection. We talked about this. We simplified the theorem, and we solved 2 problems to understand what values it can get in graph. And I said that nocturnal inflammation is important in graph because graph tells us where the Bloch sphere is. Always in 0, 0. We should draw that to identify how much the vector grows until. We did the sample question. Now we do the real questions like this and this and this, right? We knew that this value equals to 1, 1 equals 1, right? So this equals to 0. I mean this equals to this. So we got this. And this is the theorem for product set theory. We simplified the product set theory like this. I mean, not simplified, we just wrote it down. And then we did the basic theorem for nocturnal inflammation into this one. We put the product set theory. Then we did this question. We did it, but this was simple. This was a little hard, this part. This was the most complicated that I've solved. And I've already solved this alone by myself, but I got the wrong answer because I made a mistake. And after that, we plugged in the product set theory. We did it, and we got this. Thank you for listening.